China's infrastructure has caused a sensation all over the world because many of its engineering projects are pioneers in the world, overcoming numerous difficulties and even breaking through the limits of human construction. Now the construction of the world's first undersea high-speed railway built with 200 billion has officially started, which is beyond the imagination of Western countries. Such a project has been successfully constructed and completed, which is a miracle in the history of human construction. In this video, let us learn more about it because China's infrastructure construction is progressing very rapidly, far beyond the recognition of Western countries. Some netizens have given China the title of infrastructure maniac. Today China has the longest operating mileage of high-speed railways, the largest number of mega bridge projects and the largest number of super-large hydro power stations in the world, but these are actually nothing. It turns out that China has once again spent 200 billion to build the world's first undersea high-speed railway and has entered a critical construction stage. It seems that China's speed has once again shocked the world. It is the Shantou Bay Undersea High-Speed Railway Tunnel. The Shantou Bay Undersea Tunnel is 9.8 kilometers long and is the world's first high-speed rail tunnel that goes from the bottom of the sea to connect the two sides of the Taiwan Strait. At present, the common undersea tunnels in the world are generally tunnels for cars and trains. For example, the Paiyan Tunnel in Japan has a total length of 54 kilometers and a depth of 240 m. It is a tunnel that can only be used for trains. There is also the famous Undersea Tunnel in the English Channel with a total length of 51 kilometers, which is also a tunnel used for trains. In addition to these, friends who have been to the Hong Kong Zhuhai-Mao Bridge will definitely know that the Hong Kong Zhuhai-Mao Bridge also has an undersea tunnel which is not only 5.6 kilometers long but is only used for cars. Therefore, there is no tunnel leading to high-speed rail in the world. Faced with this situation, China, as the largest country in high-speed rail with a total high-speed rail mileage accounting for 2/3 of the world, has already mastered high-speed rail technology. Under such conditions, it is fully capable of building the world's first dedicated undersea tunnel for high-speed rail. This undersea tunnel connects Shantou City and Shunhu City, Guangdong Province, China. The undersea tunnel part is 9,781 m long. The structure type is a single-hole double-lane tunnel and the design speed is 350 km/h. After the undersea tunnel is completed and open to traffic, fixed high-speed trains can pass through the undersea tunnel at high speed in just 100 seconds. When it comes to the two projects of high-speed rail and tunnels, China has mastered sophisticated technologies. However, the combination of high-speed rail and tunnels is not just as simple as 1 + 1 = 2. Various factors for the combination of the two must be taken into consideration. For example, if an undersea tunnel passes through multiple geological faults, how to ensure the smooth operation of the high-speed rail. In the face of complex water changes, how to ensure that the tunnel is not affected, as well as the operation of high-speed rail and the construction safety of tunnels under the high water pressure of undersea tunnels, etc. But what can be done to stop our infrastructure crazy Chinese engineers? Previous undersea tunnels were basically used for cars to pass by ordinary trains. The Shantou Bay Undersea Tunnel is used for high-speed rail. We must know that the speed of high-speed rail is as high as 350 km/h, so its requirements for tunnels are also very high. Ordinary train tunnels simply cannot meet the operational needs of high-speed rails, and a submarine line must be specially built to allow trains to travel at full speed. The area where Shantou Bay is located happens to have a very complex seabed topography. The Shantou Bay Undersea Tunnel is located at the entrance to the sea downstream of the Shantou Bay Bridge. It is located in an 8 degrees earthquake intensity zone. It has passed through 17 fault fracture zones, making it the most underwater tunnel at home and abroad. The construction of this tunnel is extremely difficult and the risk factor is extremely high. It is a high-risk, important and difficult project on the entire Shantou high-speed railway. The Shantou Bay Undersea Tunnel is divided into a sea section and a land section. The sea section is 3 kilometers long and has a maximum burial depth of 56 m below the sea surface. It also needs to overcome the high-pressure seawater environment. The maximum water pressure in this sea area can reach 0.97 MPa, and the pressure generated can spray water to an altitude of 97 m. Currently, there is no undersea tunnel in China with such a high water pressure risk. When constructing on the seabed with a depth of 100 m, in addition to solving many complex geological problems, there are also many unfavorable construction factors that are combined together. The sea winds here are strong, the waves are high, and the currents are fast. Under the huge seawater pressure, it is really difficult to cross Shantar Bay. Seawater is highly corrosive. Long-term immersion of any construction materials is a very, very severe test. Any technical problem will lead to immeasurable hidden dangers. These technical risks are too great and the construction difficulty is too great. Moreover, explosives cannot be used to blast large underwater rock areas. There are so many problems that are weighing on the shoulders of the construction team like a mountain. Laying immersed pipes cannot cope with such sea areas where the flow rate is too high. Once the underwater rocks are broken or damaged during excavation, there will be great obstacles. Super technical difficulties are before our eyes, and even Western engineers believe that this is an undersea tunnel project that cannot be completed. As a foreign company, we simply dare not imagine it, let alone take on such a difficult project. China's high-speed rail is designed to run at a speed of 350 km per hour on the Guangzhou-Shantar Railway. After passing through the undersea tunnel, it smoothly passes through Shantar city, connecting the traffic in the entire Guangdong province, forming a fast road that runs at high speed in the province. In order to achieve this goal and contribute to economic construction, the China Railway 14th Bureau has taken on this arduous task and must ensure qualified completion and delivery. This makes it unimaginable for many Western countries and considers it an engineering goal that cannot be achieved even if they bite the bullet. It is understood that the Shao Bay Tunnel adopts a combination of construction methods such as open cut method, shield method, and mining method. Among them, when implementing the shield method, the China Railway 14th Bureau specially used 2 large-scale submarine shield machines on the east-west line, specially customized for this project. Its Shantar Bay Tunnel East Line shield machine is the first machine to be launched into the sea. It was built by Zhengzhou China Railway Company in China and is the largest diameter slurry shield machine in China. The total length is 130 m. The total weight is 4,600 tons. The diameter of the cutter head exceeds 15 m and the cutter head alone weighs 570 tons. It is conceivable that when such a big giant works on the seabed, it will play an indispensable role in promoting the entire project. The construction efficiency and working ability of the huge cutter head, which is equivalent to a 5-story building, are very terrifying. When the 2 shield machines dig separately on the east and west lines of the seabed, they will not damage the original structure of the seabed and will not expose construction workers to danger during construction and excavation. If a fault is excavated, the designed machinery uses the piston principle to block the tunnel, which buys valuable time for the construction workers to retreat safely and also provides safety protection for the continued recovery of water pumping operations. During the construction process, the construction team will conduct different construction solutions based on the construction difficulties caused by the diverse rock formations under the seaflow detected by advanced equipment segmenting different geological conditions. China's shield machines also play a very important role in the main construction work. They remain stable during excavation and can transport gravel and sediment behind while improving efficiency. The shield machine reduces the workload of SUBC workers, greatly protects the safety of the construction team, and makes the progress of the entire construction period smoother and more efficient. On March 10, 2020, the construction of the Shantar Bay Undersea Tunnel project officially started. After 3 years of construction, the Shantar Bay Undersea Tunnel is about to be fully completed and is expected to be completed by the end of 2024. With the completion of the Shantar Bay Undersea Tunnel and the opening of the Shantar high-speed railway, the time from Shantar to Guangzhou will be shortened to less than 1.5 hours, which is of great significance to Shantar's full integration into the Guangdong-Hong Kong-Macau Greater Bay Area and the construction of a 1.5-hour economic circle in Guangzhou. After the project is completed and open to traffic, it will help Shantar Port expand its northward radiation depth, provide convenient access to the sea for surrounding provinces and cities, and also provide convenient conditions for the efficient collection and distribution of regional material elements. It is of great significance to building a modern port city on the southeast coast. Thank you for watching. If you enjoyed this video, don't forget to like, comment and subscribe to our channel for more great content. See you next time.